Quantum artificial intelligence. What is it and what are its applications? I'm going to tell you about it today. Let's get into it. In the ever-evolving landscape of artificial intelligence, AI, a groundbreaking frontier is emerging, promising to revolutionize the way we process information and solve complex problems. Quantum artificial intelligence, QAI, is not just a buzzword but a paradigm shift that taps into the principles of quantum mechanics to enhance the capabilities of traditional AI models. As we delve into this uncharted territory, let's explore the fundamentals and potential applications of quantum artificial intelligence. Quantum computing operates on the principles of quantum mechanics, a branch of physics that describes the behavior of matter and energy at the smallest scales. Traditional computers use bits, represented as either zeros or ones, to process information. Quantum computers, on the other hand, leverage quantum bits or qubits. Unlike classical bits, qubits can exist in multiple states simultaneously, thanks to a phenomenon called superposition. This allows quantum computers to perform complex calculations at an exponentially faster rate than classical computers. Quantum entanglement is another key concept in quantum computing. When qubits become entangled, the state of one qubit is directly related to the state of another, regardless of the distance between them. This enables quantum computers to exhibit a level of parallelism that classical computers can only dream of, unlocking unprecedented computational power. Challenges and opportunities. While the potential of quantum artificial intelligence is immense, there are challenges to overcome. Quantum computers are still in their infancy, with issues such as qubit stability, error rates, and decoherence posing significant obstacles. Additionally, building and maintaining a quantum computer requires a controlled environment with extremely low temperatures. However, researchers and organizations worldwide are actively working to address these challenges. Investments in quantum computing research and development are on the rise, and collaborations between quantum physicists and AI experts are becoming more common. If you enjoy learning about artificial intelligence, please like and subscribe to ensure more videos like this. And let's continue. Here are some promising applications of quantum artificial intelligence. Optimization problems. QAI excels in solving optimization problems, such as route optimization for logistics, scheduling, and resource allocation. Quantum algorithms can explore a vast solution space simultaneously, leading to more efficient solutions for real-world problems. Machine learning enhancement. Quantum computing can enhance machine learning algorithms, accelerating the training process and enabling the analysis of more extensive datasets. Quantum algorithms like quantum support vector machines and quantum neural networks have the potential to revolutionize pattern recognition and data classification. Cryptography. Quantum computing has the capability to break widely used encryption algorithms through its superior processing power. On the flip side, QAI can also contribute to the development of quantum-resistant cryptographic techniques, ensuring the security of data in the post-quantum era. Drug discovery. The complex nature of molecular interactions makes drug discovery a computationally intensive task. Quantum computing can model molecular structures and interactions more accurately, significantly speeding up the drug discovery process and facilitating the design of new pharmaceutical compounds. Financial modeling. Quantum computing can be applied to complex financial modeling tasks, including risk assessment, portfolio optimization, and option pricing. The ability to handle large-scale computations simultaneously allows for more accurate predictions and better-informed financial decisions. Climate modeling. Climate simulations involve processing vast amounts of data and complex interactions between various environmental factors. Quantum computers can contribute to more accurate climate modeling, helping scientists understand and predict climate change patterns with greater precision. Artificial intelligence robustness. Quantum computing can be used to enhance the robustness and security of classical AI models. Quantum machine learning algorithms can help identify and mitigate vulnerabilities in AI systems, making them more resistant to adversarial attacks. Supply chain management. Quantum computing can optimize supply chain logistics by efficiently solving complex routing and scheduling problems. This can lead to cost reductions, energy savings, and improved overall efficiency in the movement of goods and services. Genomic analysis. Analyzing large genomic datasets is a computationally demanding task. Quantum computing can accelerate genomic analysis, enabling researchers to identify genetic patterns and variations more quickly, which is crucial for advancements in personalized medicine and understanding genetic diseases. Materials science. Quantum computing can simulate the behavior of molecules and materials at the quantum level, leading to discoveries in the development of new materials with unique properties. This has implications for advancements in electronics, energy storage, and other material-dependent industries. As quantum technology continues to advance, the practical applications of quantum artificial intelligence are likely to expand, ushering in a new era of computing capabilities and problem-solving approaches. Quantum artificial intelligence is not just a theoretical concept, it's a tangible and transformative force that has the potential to reshape the technological landscape. As we stand on the brink of this quantum frontier, the fusion of quantum computing and artificial intelligence promises a future where computational boundaries are pushed to unimaginable limits, unlocking unprecedented solutions to some of humanity's most complex challenges. If this video was of some value to you, please like and subscribe. Please take a look at the video I have placed on the screen and enjoy. Comments and suggestions are welcome. Thanks for watching.